Good morning everyone. This is series of lecture for T.Y.B.Sc analytical chemistry semester 6 students. The course of the subject is CH611A. The chapter we are going to study is chapter number 6, flame emission spectroscopy. Now here we are going to learn about the detector used in the flame photometry or flame emission spectroscopy. The detector is photomultiplier tube. It is also called as a PMT. Only this single detector used in the flame photometry or flame emission spectroscopy. Here the photomultiplier tube, its a principle, construction and working is given, and diagrammatic representation is also given. Now here it consists of a cathode, anode and many additional electrodes called as a diode. The first point is that it consists of a cathode, anode and many additional electrodes called as the diodes. Now here the diode system is nothing but the additional type of electrode system placed in an evacuated tube in photomultiplier tube. Now the second point is that all these are enclosed in an evacuated quartz tube. Now in that evacuated quartz tube, cathode, anode and diode are placed, and they are placed in such a fashion that the ejection of electron takes place in a proper manner. Now the second point elaborates, or the second point tells us all these are enclosed. All this means what? Cathode, anode and diodes are enclosed in an evacuated quartz tube. Now quartz tube is nothing but the silica, that is SiO2 n times. The inner surface of the cathode is coated with a light sensitive material like cesium oxide, that is CSO, or potassium oxide or silver oxide. The cathode surface is made up from one of the three components, that is nothing but the cesium oxide, potassium oxide or silver oxide. Now these oxides are sensitive to the photons, or you can say the light. Most photomultiplier tube have 9 diodes. So mostly in the PMT 9 diodes are placed. Each diode has ability to emit 2 to 7 electrons from its surface where a light is incident on it. Now every diode has the ability to eject 2 to 7 electron when a proper light having a proper wavelength is incident on its surface, that is the cathode surface. Now the third point is that when a light of suitable wavelength strikes the cathode surface, ejection of electron takes place due to the photoelectric effect. These primary electrons are attracted towards the first diode placed at 75 to 100 volts due to the electrostatic field with the ejection of 2 to 7 electron. Now the third point tells us that the ejection of electron takes place from the cathode surface when a light of proper wavelength is incident on its surface. Now this is because of the photoelectric effect. So photomultiplier tube is based on which effect, or what is the principle? That is nothing but the photoelectric effect. These primary electrons are attracted towards the first diode. Whatever the electrons which are ejected from the metal surface, or you can say cathode surface, there is a ejection of primary electron takes place, and these primary electrons are get attracted towards the first diode. Now first diode has a voltage that is 75 to 100 volts, and the attraction takes place because of due to the electrostatic field between the cathode and diode, that is the first diode, and this first diode gives the 2 to 7 electrons. The produced secondary electrons are attracted towards the second diode. Now whatever the electrons which are ejected by the first diode, they are attracted towards the second diode. Now this there is a multiplication of electron takes place successively. The produced secondary electrons are attracted towards the second diode placed at same voltage. Same voltage means what? 75 volt or 100 volt up to 100 volt. Now this second diode also gives the several electrons with the ejection of several electrons from its surface. This process is repeated at least 9 times. So 9 times means what? There should be 9 diodes are placed at a one time in photomultiplier tube. Each incident photon is capable to give 1 to 10 electrons. Now a single photon has the ability to eject the 1 to 10 electron from the cathode surface, which is made up from cesium oxide or alkali oxide or silver oxide or potassium oxide. Finally, all electrons get discharged at anode or collector. Now here cathode is a negative charged and anode is always positive charge. So every electron which are coming from the successively diode will be get discharged at positively charged electrode, that is nothing but the anode, which is also called as a collector electrode. The anode is also called as a collector electrode, which is positively charged. The resulting current is then amplified, measured by a readout device. Now whatever the ejection of electron takes place successively, they get discharged at the anode or collector electrode, now which result into the current. Now this magnitude of this current is directly proportional to whatever the current which is given by the anode. The resulting current is then amplified and measured by the readout system. So readout system is nothing but the combination of computer control service. So computer control system is placed to measure the current in the form of meter or digital signal. The magnitude of current is directly proportional to radiant power of incident photon that strikes the photocathode. So this is most important line here. The magnitude of current which is given by the readout system or current digital signal, which is directly proportional to whatever the amount of radiation is incident on the cathode surface, or can say photocathode surface. Now photoemissive, it is also called as a photoemissive surface because it gives the emission of electrons from its surface. So cathode surface also is nothing but the photoemissive surface. So this is the diagrammatic representation of the photomultiplier tube. Now here the overall amplification is about 10 degree centigrade, 10 degree or not centigrade, it is a 10 degree. That means the amplification it takes place up to 10 degree. The overall amplification factor is about 10 degree, and this is the diagram of the photomultiplier tube. Here cathode is there. This is the cathode. This line is nothing but the cathode. This arrow indicates the cathode. This cathode is made up from alkali metal oxide surface. Here ejection of electron takes place. Sorry, incident light is incident on its surface. Now here the ejection of electron takes place towards the first diode. Now here this thin line is converted into successively thick line. Now this thick line is nothing. It is come from the diode surface. Again it is attracted towards the second diode. This again there is a multiplication of electron takes place, and this multiplication of electron is indicated by thick dotted lines, and these thick dotted lines are nothing but the number of electrons which are come out from the diode, and all these electrons will be get discharged at the surface of anode, which is positively charged, and here electrical current is produced, and this current is measured and amplified about up to 10 degree. So this is important factor. And finally whatever the amplification it is measured by the readout system or readout device. So this is all about the, we can say, about the photomultiplier detector used in the flame photometry. So in that chapter we have already learned about the principle, introduction principle, type of the burner used, then there is a slit, entrance slit, exit slit. In that between monochromatic system is placed. This three system is also called as a optical system of the instrument. And after that optical system and detector is placed, and that detector is nothing but photomultiplier tube. With this content, I conclude this lecture. Thank you very much for your patience listening.